Precalc, this is chapter 1.6. Guys, hopefully we're going to like this one because it's just function operations and composition. Which means I'm going to add, subtract, multiply, and divide fractions. For the most part, I don't think there's going to be too much issues with what we're going to do here, but the issue that's going to come down to is people always don't follow directions, and they think anytime I have a function next to a function, I need to multiply. And that's not necessarily true. And so, what we need to realize is that there are 4 different operations right here on this page that we can do with functions. The first one up is addition. And there are 2 ways of writing this. And so these 4 are the sum. So that means if I take f plus g of x, I get f of x plus g of x. I just add the 2 functions together. I also have the difference, f minus g of x. That's f of x minus g of x. And if I go over to product, f times g of x, I get f of x times g of x. And the last one is quotient. F divided by g of x is f of x divided by g of x. And anytime you have a function on the bottom, you cannot let it equal 0. So g of x cannot equal 0. These are the 4 main types of operations that we will apply today. And I'm hoping you guys are like, okay, I've seen these before. These shouldn't be too bad. But the biggest thing is people get mixed up the sum and the product. They change an addition sign. They think that this means FOIL or multiply. You do 10 times more work when you multiply fractions together than when you add them. And so don't do that. Do what the operation says. And the biggest thing is that your answers should always be fully reduced, simplified, and a lot of times that means you have to factor sometimes when you're dividing or just gathering like terms. Put things together. And so what I want you guys to do is I want you to apply all 4 of those from above here with an f of x, which is equal to x minus 4, and g of x is 9 minus x squared. Okay? And then at the end, we'll come back and we'll talk about the domains of each of these, because I think that's an important thing to talk about. So I'm going to pause the video, give you guys some time. If you're watching the video, it seems like no time has passed. So, part A, we'll call it A, is the sum. When does f of x plus g of x? Okay, so now when I do this, guys, I am actually taking f of x out and replacing it with its value. Its value is, don't think of it as value as a number, but what is equal to f of x? X minus 4. And so, if I replace it with x minus 4, I'm going to use parentheses. I'm using substitution. I cannot stress enough that when I am doing this, I need parentheses up front. After this, I'm going to evaluate, and I'm going to ask myself, do I need these parentheses? And the question, or the answer to that question is, no. No, I don't. And so now I will get rid of them.
So what's the purpose of having them before?
Because at sometimes there will be a point and a reason to have it, like when we do the subtraction.
Okay, so we'll come ahead.
It's going to, by putting them there all the time, you're going to free yourself from making mistakes. Okay, guys? We have this. This is the answer, but I wouldn't say it's an acceptable form. We want to put it into what form? The right form, which would be called standard form. So standard form puts the highest exponent first, which is negative x squared. Then moves on to x. And then it looks like I can put the two terms in the middle. Negative 4 plus 9. 5. So that would be the sum of the 2 equations. Part B. What happens when you subtract them? And then this is where I think it's going to be very important to have your parentheses. So what is f of x minus g of x? Now, guys, be very careful that I could have this as g of x minus f of x. I could have this 2 times f of x minus g of x. So there's different forms of this. You just have to know that you're multiplying a function by 2 or a half or which ones you're subtracting from where. So again, f of x is x minus 4 and minus 9 minus x squared. Now you can ask yourself, do I need those parentheses? Do I need them on the first group? No, I really don't. So this becomes x minus 4. But of that second group, wait a minute, there's a negative 1 out front. Is it important to have the parentheses now? Because I need to do what? I need to distribute the negative. So it's minus 9 plus x squared. Again, put them in order, standard form. X squared goes first. Then it goes plus x. Gathering up the middles now. Minus 13. There should be a difference between adding functions together and subtracting them, yeah? And there is. Moving on to multiplying. Part C. F of x times g of x. Which means x minus 4 times 9 minus x squared. If you did not use parentheses on this, you could definitely get some weird numbers. Because order of operations would take over and change the direction of your problem completely. So just be careful on that. Hey, this is a binomial times a binomial. I'll use the 4-letter F word. Foil. So, x times 9. 9 times negative x squared. Negative x cubed. Negative 4 times 9. And negative 4 times negative x squared.
Wait, what is this?
Okay, so what we have here now, we just have to put in order. And so, negative x cubed plus 4x squared plus 9x minus 36. Guys, the very important thing here is I would like to see the rainbows or the work that supports what you're connecting. If I look at your problem now that we're done with it, I cannot tell when you did those. But the biggest thing you could do to help yourself is to make one connection, do one multiplication. And if you're not following that, you very well could make a mistake. Notice there's a big difference between the answer we just got that raised our powers, got a negative x cubed, versus in the very beginning when we added. It's still an x squared type problem. So be very, 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 very careful. Follow the rules. And then the last one, which we will use blue. For part D, f of x over g of x. And so I'm probably going to run out of room here. Let's move this to the top. Okay, so move it up here. That means it is x minus 4 over 9 minus x squared.
Can we put that in parentheses or?
Wait, is that x minus 9 or x minus 10 minus 4?
So x minus 4 over 9 minus x squared. Guys, most of the time you're done. But when we do something like this, we're putting functions together, and now there might be some limitations that were not there before. First of all, am I completely simplified?
No.
No.
You might not be. Actually, this variable could be simplified, which means I can't cancel anything. So for us, I would say break it down. And I think everybody would agree x minus 4 cannot be broken down anymore. But 9 minus x squared, that's a square minus a square. That's the difference of squares, which can be written as the sum and difference. What's being squared to get 9?
3.
How about x squared? One of these needs to be minus, and the other one is positive. Now, can I cancel anything top to bottom? And no, x's are not an option here because I cannot take an x off the top and the bottom.
You can't.
So, here's the thing. If you guys came walking into the room and saw this answer, could you verify that you are 100% completely broken down, simplified as much as possible? No, because you should recognize that the bottom does factor and there could be something that could cancel. But if you walked into the room and you saw this answer, can you see that nothing will cancel? Yes. Could you also tell me that the function cannot be what values? What x values can you not put in? 3 and negative 3 because they'll make the bottom equal 0. Those are actually vertical asymptotes. So these are all things that you guys you can get by simplifying it, factoring it down to its most simplistic pieces or parts. Okay? Now we got to go back and talk about domains for all of these. Yes?
Is that a 9 or is that a 4 on the bottom?
That is a 9 minus x squared.
Looks like a 4.
And then, so for our domains, here's the thing. If I go back to my originals, my original was an x minus 4. That's a line. Is there any restrictions on an x minus 4 line? Are there any values of x that I'm not allowed to put in? So what would x values be on that? What's the domain of that problem? What's the domain of x minus 4?
Equal to positive and negative.
Positive to negative infinity, basically all real numbers.
Wait, this for A part.
This is being for the domains.
Part A.
Not part A, I'm just looking at f of x right now. F of x is all real numbers. G of x, 9 minus x squared. Is there anything I cannot put in there and square it and subtract 9? Or subtract from 9? I don't think so, right? So therefore, it's all real numbers again. If I took a function that was all real numbers and added it to another function of all real numbers, the answer that comes out is all real numbers. Hence, the answer here was a quadratic. That works fine. Wait a minute, if I subtract an all real from an all real, I still have an all real domain still. I multiply an all real times an all real. The answer is all real. Problem. I take an all real divided by an all real. Is the answer that comes out all real still? You would almost think it would be, except for when you have a fraction, you now say, wait a minute, in this particular fraction, I cannot be what values? We already stated it. 3 and negative 3. Because I can't be let it equaling 0 on the bottom, in the denominator. So this is all real numbers except 3 and negative 3. So putting these together, it joins their pieces together. If one of these happens to have a limitation, it's going to play with this. So, let me change it now. Let me change this. If I use this green color, what if that x minus 4 was really the square root of x minus 4? So now we're not talking about having that all real numbers. If it's a x minus 4, what would be the domain of the square root of x minus 4? X has to equal, or greater than, or equal to what? 4. So wait a minute. That means if I join something with a domain where I'm only allowed to put 4 or greater in, with an all real, their joined domain actually defaults to the greater than or equal to 4. Because I'm not allowed to put into the one part of that function anything less than that. So when you add, subtract, multiply, and divide, you have to watch out for any extra stuff that pops in there. But then when you add, subtract, and multiply, you always take the least restrictive. Or the most restrictive, sorry, right? Most restrictive. The x greater than or equal to 4 is the most restrictive of our new group, so therefore it will default to that one. Okay? Because you're using both of them at the same time to talk about the same x. Questions? Next group, composition of functions. This is the last one. Well, the last main idea. We're going to put it together and then we're going to break it apart. So, the composition of a function f with function g is defined by f open circle g of x, or f of g of x. The one thing they don't show on here is the other way. So I'll put that in here too. We also could have g f of x. I like to color code mine sometimes. What you need to recognize is that one function is inside of another. This just equals g o f, right? Of x. One function is inside of the other. The domain of a composition, that it says all the x values in the domain of g that map to the g of x, y values in the domain of g. Guys, composition. If I plug one function inside the other, that means that the original function, it's kind of like an assembly line. The first thing is always the most inside piece. I'm going to put x values into that, and I'm going to get y values out. Those y values are now the inputs to the one outside of it. And so if there are multiple parts inside of each other, compositions, you're always using the output as the new input for the function that's next. Like the assembly line. One person puts on a part, hands it to the next person. They use that now to build the next one, and the next one, and the next one. So there's read as f composite g, g of f of x, things like that. So our problem below is I want you to do both f of g of x and g of f of x when f of x is the square root of x plus 1 and g of x is x squared minus 1. And then at the end we'll talk about the domains of these ones and how they actually can get pretty messy sometimes, because sometimes you don't have to worry about your outputs and sometimes you do. So again, I'm going to pause the video. You watching the video, pause it as well. Try it. Hopefully we're recognizing something. It seems a little different, but yet should be familiar. So, first one I want to do is f of g of x. Now, I'm going to show you guys this color-coded, and I'm going to take it one step at a time, please. What I want you guys to do is say, I am going to take out x's, and I'm going to replace it, the x's of f of x, and replace it with g of x. It's like I'm transplanting flowers here, guys. So, would you guys agree that if I took f of x, and I wrote it down and took out x, just boom, pulled it out, I'd be left with this void that needs to be filled in. Used to be an x there. And inside that void, I am going to place g of x. Now I'm taking my time, I'm showing you step by step. So what does that mean? It means that actually I have the square root of f of x plus 1, which f of x is, or g of x, sorry, x squared minus 1. Now the question is, do you need those parentheses now? No. And so I would have the square root of x squared minus 1 plus 1. What happens to the 1s? Hey, wait a minute. That means I have the square root of x squared, which equals? X. There you go. Composition resulted in x. If I apply g of x, bless you, and then turn around, take that answer and put it back into f of x, I get x out. I put x in, I get x out. Interesting. Now, what happens if I take g of f of x? Which means I have something squared minus 1, yeah? Ripping out the x, what goes in there? F of x. And so, I would have the square root of x plus 1 squared minus 1. Wait a minute, what happens to this square and the square root? Cancels, so I get x plus 1 minus 1. Those cancel, leaving me with x. Boom. Wait a minute. When both of these ways work that exact same way, there was a name for this. We're actually going to learn about it tomorrow. It's got a special name. They just undid each other. Basically, they are, starts with an I. Inverses. Guys, that's how you show inverses, right? If f of g of x equals x and g of f of x equals x, they are inverses. They undo each other. I start with x, apply a function to get some answer, and then I put that answer into the other, and it brings me back to the beginning. What I put in. It's like you're going down the assembly line, someone puts the top part on, and the next person takes it off. That's what they're doing. Yeah. Now, on these ones, the domain are kind of tricky. Because I think if everybody looks at the square root of x plus 1, can everybody agree that x has to be greater than or equal to 1? And the other one, x is all real, because it's quadratic. They're all real. If I'm putting them together, doesn't it kind of seem that it should just make it so that the combined efforts of this would just say, hey, only when x is greater than or equal to 1? But take a look at our answers. Both of our answers just say they're x. And x itself is all real numbers. So why doesn't that seem to work? Wait a minute, this one right here. I have to take g of x, which is a quadratic, and I need to add 1 to it, right? And if I add 1 to it, I end up with an x squared. Can I put anything I want into an x squared? And what happens when I square any number? It always becomes, and so if I take a square root, I am A-OK, ain't I? Well, that's just interesting. So it kind of washes that out. So what I need to say is that you can't just necessarily look at what they are and say, oh, it's the least restrictive, or the most restrictive, I guess you say. I think you got to kind of individually take a look at it and say, okay, what can I be, what can I not be? Because if negative 2 works here, does negative 2 have to work here? And it's no. Because on this one, you can see that the square root's inside. So negative 2 plus 1 is negative 1. I can't take the square root of negative 1, even though I know I'm going to square it at the end. So therefore, negative 2 does not work. The answer to this one, domain, is the x is greater than negative 1. Because remember, when you do composition, the inputs to the outside function are actually the outputs of the one inside. Because here, f of x is being taken on g of x. G of x is just a fun way of saying y. So it's actually the outputs of g, not the inputs. Just like this is the outputs of f that get applied to inside G. So be careful on that. There's one last thing that we got to talk about. Decomposing a composite function. Basically says that if you're allowed to put functions together, could you break them apart? Here's a key. The key for you guys should be, hey, think of all those parents we just dealt with for a really long time. If you can identify or visualize what one of those parents are in one of these, you're golden. Because therefore, your outside function can be the parent, and then you will put something else into it. Take a look at the h of x there. I want an f composite g of x. I need an f of x, and I need a g of x. Where f of x is my outside function. So look at 1 over x plus 7. That really looks like what kind of function? What would be the parent function to something like that? 1 over x. And so if that's 1 over x, what does g of x have to be plugged into that to get 1 over x plus 7? Not 1 over 7. How about just x plus 7? Because when I put g inside of f, I take out the x here and replace it with x plus 7, which is h of x. Sometimes there's more than one answer. So be very, very careful on this. Like part B, there are multiple parts to this. I think the outside function, this bigger function, doesn't it look like a quadratic to you guys? So, what happens if I did this instead? What does g of x have to equal? I just somehow lowered the powers. And we did this, guys, when we were factoring quadratics. If it was in quadratic form. This because g of x would just have to be x squared. Because then I would square x squared to get x to the 4th, and x would become x squared. That's not the only option. Another option. What happens if I said that f of x is x plus 8? What does x have to be to put the rest of it there? What's missing up here? A negative 3 x to the 4th minus 2x squared. Okay? Homework. Page 61 on 1.6, 1, 2, 5, 15, 16, 30, and 31. Have a great day. Don't do anything stupid.